Welcome back to the Automate Construction Podcast. I'm here with Keith Comstock, Executive Director of Extreme Habitats Institute. Executive Director of Extreme Habitats Institute.
Yep.
Keith, thank you for having me up here in Alaska.
Glad you're here. Welcome to Alaska.
So we're in Nome, which I would describe as a remote village. The locals seem to think it's a big city.
Well, as far as the scale of things go, yeah, Nome is kind of the at the level of still of a city, considered a city in Alaska, but it's kind of on the edge between a city and a village, and then it gets much smaller and difficult to access from here.
So of course the reason I'm here is because you guys developed a concrete 3D printer with XHAB, and to set the frame, we're in one of the westernmost regions of Alaska.
Yes.
And there's some extreme weather conditions. It's the summertime, so it's not as cold as it usually is, but it's been 50 degrees, rainy. You guys are really battling the elements up here.
Windy. I've had to break ice out a couple times in the early mornings. So it's not going to get warmer.
Can you describe the project you guys are working on up here?
Sure. Well, we're working on a project to bring a 3D printed home to Nome. Nome is a very interesting city. We're very close here to Russia, the Seward Peninsula, the Bering Land Bridge. We all learned in school about how maybe our ancient ancestors walked across that Bering Land Bridge. It's just right out the end of the road here. It begins, and it's becoming more and more important geostrategically as the Arctic opens up and shipping routes and military things. And so Nome is experiencing a bit of growth. The housing here is not adequate for that growth, and we're exploring ways to look at affordable construction techniques. And so the 3D project is kind of part of that.
Even this house, the Airbnb I'm staying in, has a remediation sticker on the window. And when I walk up there or hear somebody walking up the steps, I can feel the whole building shaking from upstairs.
Sure. Well, we're kind of in the center to eastern part of the town. Basically the Bering Sea is just to our south here on the Seward Peninsula. And as you move away from the original downtown and head further east here, you start running into permafrost issues, which is which means that the houses are in movement.
Mm-hmm. You did show me a house near your print. They put on adjustable stilts.
Yes.
What are those called?
I don't know the exact term for them, but they're just basically that. They're basically adjustable pilings. There's different ways to build here. Certainly where we're building, we're in the old part of town. The ground there is pretty good. We even have some homes nearby that have basements. That's very unusual for Alaska.
Mm-hmm.
As a kid who spent time out at Offutt Air Force Base and at Wright-Patt Air Force Base as a military brat, seen a few tornadoes and had to go to a basement more than once. That's not a big issue in Alaska. We have other issues. There are polar bears here, but we found a place that would be good for a 3D print. Like probably this location here, because of what you're experiencing, would not be okay.
Your project, the first time we were working on here, is not on a permafrost site. 1,500 square feet?
About 1,500 square feet, yes. 3 bedroom, 2 bath.
How long were you talking with the city to bring this to fruition?
I think we started working on this in about 2002, working with them, working with the Nome Eskimo Association, the local tribal organization here in town.
2002?
I'm sorry, 2022.
Okay.
Sorry about that. You can cut that out, I suppose.
So
we'll fix that in post, right?
2022.
2022.
You start talking with there are the Eskimos here, and I was talking to somebody in the lower 48 about Eskimos, and they said, that's racist, you can't say that, but these are actually...
It's the Nome Eskimo Association. These are Yupik people. They're wonderful people, some of the nicest people I've ever met.
A few of your team members have been printing concrete for 6+ years, involved in the NASA Search Plus competition.
Sure.
In 2002, what stage were you guys at in terms of...
2022.
2022. What stage were you guys at in terms of preparedness for printing? Had you developed the printer yet? Did you have a
No, no. Well, we were looking at it, because of the leadership of the Dunleavy administration, we were, looking at ways to bend cost curves. And I was working for the Department of Commerce at the time and looking at ways that we could more affordably construct. At the time, our prices were several $100s a square foot less than they are now, but it was way too high then. It's even crazy high now. We have some of the most expensive prices really in the world to build with, especially when we're talking about villages. But a lot of that has to do with the transportation and shipping costs, and the fact that basically every component for a house or any kind of structure is imported from at least the lower 48, and maybe imported internationally as well. We're looking for ways to build locally. Certainly where I live in Juneau, Alaska, there is timber available, although that's highly controversial. But there are some trees that can be used. But here we're above tree line. You might find a few trees where it's sheltered, so like up close to a house. But anywhere that it's open, you'll basically never see a tree that's much higher than 4 or 5 feet. It's just the conditions are too harsh here. And so we were looking for what could we build with, and started looking at aggregates and bricks, sand, gravel as possible building material. And so with the help of the Alaska Housing Finance Corporation, started a study to look at where these materials exist, how might they be used, and what it might cost to do that. Now, what we didn't know when we started this, and I'm sure that lots of people did know, we just didn't know, was that historically, before globalization, Alaska had been a producer of concrete materials, cementous materials, to the West Coast, to Seattle, San Francisco, cities below and between, to build. And so we have a lot of limestone resources, which are used to make clinker, which is then ground up to make cement. And we had a history of exporting those to the lower 48 as part of the supply chain. Now I think those are probably coming from Indonesia or somewhere far, far away where so the materials are all here. So we're in the process of classifying and then studying them, and then figuring out how to make mixes so that we can get the cost down, because it's extremely expensive. Of course, in the Midwest, where we have a lot of that good material, Indiana's famous for its limestone. There are concrete and cement quarries everywhere, and so in the middle of the country, it's all produced locally. But as you get over to the coast, I think a lot of it comes in internationally, because it just becomes cheaper when you're moving things by ship. But it's of course, we're under the Jones Act, for those who really want to go deep. But that basically restricts the kind of vessels that are allowed to bring goods to Alaska. So there need to be American-built, American flag vessels, which I'm certainly for. But again, that's it's many times more expensive to move a good from, say, Seattle to Alaska than it is to bring it from parts unknown to Seattle.
So the primary advantage is local material procurement.
Local material. Yeah, to then cut that, to get the cost per ton of material down to a manageable level.
And then labor is also very expensive up here.
Yes, labor is expensive in Alaska. And then skilled labor in Alaska is expensive. That is an issue everywhere. A lot of the projects that I'm aware of have been involved in peripherally. They'll work. People will work for like a 2-week shift, 12 hours on, 12 hours off, and then they'll rotate out for 2 weeks. And that's very common in the oil fields and folks working in mining and other kinds of fields here in Alaska. But things are expensive. When I've been involved in projects where I've had to hire folks, something that's a big deal down in the lower 48 is something called Davis-Bacon wages, and folks who are in construction are oftentimes upset about having to pay Davis-Bacon wages. Here in Alaska, that's really not an issue.
What is that?
Well, that's basically a federal minimum wage that has to be paid, especially if there's it's like a highway project or any kind of federal money is involved. You know, you basically have a minimum wage you have to pay for certain types of labor.
Do you know what that's set at?
I don't know what it's set at. It varies by state and region, but here, you know, it's quite aggressive, and of course, it depends upon the type of work you're doing. And so the feds have a published sheet. But typically speaking, if you can find somebody good and qualified, you're at or above that, whether they're union or non-union here. Just getting good quality people costs. And so, you know, we were able to build a relationship with our local union here, and, you know, and found really no difference in qualified laborers who are being paid union wages here versus non-union wages. It's just not. It's not a differentiator here like it might be in Texas or, you know, in Alabama or somewhere in the southeast where, you know, things are a little different.
Is it just the local union, or is it a bigger union group you guys are involved with?
Well, we started out working with Local 528, which is based out of Seattle, and they're kind of the lead for the union on all things 3D concrete printing. You know, we didn't know that when we started working with them. We just knew that they were our local union, and we were working with the folks here out of Anchorage. But they've been incredible to work with. And as we've built that relationship, we were then able to build a relationship nationally as well. So we're a signatory on a national contract, and have actually performed now work outside of Alaska with Alaska trained labor. And again, you know, when you're talking about a 3D printing project, the labor is really not the determinant price, because you've got, you know, a couple folks, 2 or 3 folks working on the machine itself, and with a little luck, unlike here in Nome, a little luck, you know, you're in and out in a matter of, you know, days or weeks. At the maximum, you know, a couple weeks on a house, and you know, all things being equal, that's not going to make or break a project. But you know.
Yeah. So the unions will allow you to scale up quicker, hopefully, right?
They will, and certainly, you know, I could not afford to have the level of staff and skills that are available to me. You know, we're a small, Juneau, Alaska-based nonprofit research institute, and, you know, with a phone call, I can, you know, have a large work crew at my disposal immediately. And, you know, but where we worked so closely with the folks there is, you know, training. And so, you know, I basically have loaned them my printer. They've set up a training facility out in the Mat-Su Valley, and we're training folks all winter long. So, you know, right now I've got probably more people trained than I have projects available for them, but that's changing.
So this first house ideally would be the seed that would grow into a lot of military housing would be the goal, or?
Well, I don't know military housing necessarily. I mean, we're, you know, certainly the military is looking at being here in a bigger area, and what they will do with their own housing, they will do. But, you know, usually, you know, as a you know, a kid who grew up on or adjacent to military bases, typically not everybody who fits on the military base, and so there ends up having to be community housing as well that the military folks are often in. And, you know, basically, I remember that as a kid, that, you know, you would, my father would either, you know, be provided a house, or he'd be provided a voucher to basically go and obtain housing. And of course, you know, there's now there are differences in the amount of pay based upon your locality pay. That didn't exist a million years ago when my dad was doing that. And you know, I know he'd like to, you know, be sent to somewhere like Europe, where at the time there was a big difference in you could have a pretty nice house for what they were providing. Less so if you were in New York or San Francisco or Washington, D.C.
That's interesting. I imagine that would be like cost prohibitive. How can you give everyone the same stipends when causing the cost of living in New York might be 3 times more than?
Yeah, well, now they do that. Now there's a pay differential, but back in I don't know when that changed, but I was a kid of the 70s, And at that time, there was not. And so if you were, you'd much rather be sent to Omaha, Nebraska than Washington, D.C. or New York because, you could, if you weren't provided home-based housing, you got a much nicer house.
How did you make the jump from into entrepreneurship?
Well, I really kind of started there. I started as a tech guy out in Dayton, Ohio, working in a family tech company that we're very blessed with. Right time, right place, grew and did very, very well. Left that and spent a little time in government down south, and then ended up in Alaska raising a family and doing different kinds of entrepreneurial projects, and involved in a hydroelectric power development project called Juneau Hydropower, and have strong interest in economic development and those kind of things. And certainly big drivers of economic development are first and foremost energy costs. It's very hard to have economic growth without affordable, ubiquitous energy.
Mm-hmm.
And then right behind that is housing, transportation, schools, things that are critically important if you're going to have economic growth.
Was the hydroelectric plant your first construction related?
It was. Everything I did before that was, virtual construction. Now we would design computer systems. Sometimes those would be software and hardware, and so certainly there was a construction element. But it's more of an integrator. I mean, I didn't build hard drives. I didn't build microchips. I would buy them and configure them and install them in an environment. And so, if you want to call that construction, it kind of is. But what it really is managing very complex, large projects. And so, oftentimes you'd have large developments with many millions of lines of code and integration of diverse systems, a lot of legacy systems built in the 60s, 70s, 80s with IBM mainframes and COBOL, and then basically to integrate those and bring them into a more of a web-based modern system. So no stranger to complexity, and so building things is managing complexity.
So on this project here in Nome, is Jeff working for Extreme Habitats, or he's a separate entity as the GC?
He's our VP of construction. Yeah, he's part of Extreme Habitats.
So you guys are operating as the general contractor on this project?
We are, and we would. We're looking forward to the day that we don't need to do that, but at this point in time, we felt that was necessary to make sure that everything was brought together. And there's been so much learning. The greater automated construction community has been so helpful to us. Lots of folks freely sharing information with us. But some things you just got to learn yourself. And fortunately, by working with the union, we were able to put up wall after wall after wall segment, and then experiment with where do you put the electric, where do you put the plumbing, looking at best practices, and then what works for us here. But insulation is a big deal in Alaska. Right in a community like Nome, the standard rating for a wall is like an R50. Some people will put, R70. We're hoping to be right in between there. I think we're looking at basically an R60 wall, which is not nothing. And then, how do you do that in a concrete structure, and how do you do that where, there are water issues when you're putting foam and certain things next to concrete. There's a really sharp company down in Arizona called SWD Urethane, who's been just phenomenal to work with and helping us, develop a pour that will, it's basically hydrophobic and will go into the wall cavity without either, putting too much pressure and cracking it, or leaching too much moisture out of the walls, or adding moisture to the walls. We're very happy with our initial tests of that, and we built a test facility in Fairbanks last summer, about this time last summer. Of course, instead of being I think it's about 42 outside at the moment, it was like 92.
Wow.
Of course, Alaska's a really big place. Yeah, I live in Juneau, which is kind of the southern part of the state. It's as far from here, from Nome to Juneau, as it is from New York to like Kansas City, Missouri. So long, you know, things are far apart here, and we still got another 500 miles to the top of the state.
You can't even drive Nome to Juneau.
You can't drive Nome to Juneau. You can't drive Juneau to anywhere. You can't drive Nome to anywhere. Basically, you either come here on a boat or a plane or a dog sled. Of course, Nome is very famous for the Iditarod dog sled, which ends here every spring, and the famous thing where they make the Disney movies and with Balto and the bringing the vaccine to save the folks when there was an epidemic going on here. No, you can't go anywhere from here. And of course, in Nome in particular, in another couple months or so, the sea ice will freeze up on us, and then that basically locks out shipping until usually May-ish, late May. We can start getting barges of things in here. So about half of my stuff came over via barge, and the other half came over thanks to the Alaska National Guard.
Another aspect of your design planning you mentioned is fitting everything into the 20-foot containers.
Sure, for the 3D printer, that was a real design consideration, especially here for Alaska. We think this applies just as much to a construction company in the lower 48 who wants to get into 3D printing. We wanted to design a printer that could fit into a 20-foot Connex, and a 20-foot Connex, that's small enough that you can put one of those on a trailer and haul it with an F350 or 450, at least a 350, and you can haul basically so a dually, which are very common in construction. So you can basically take that, haul it to your site. The machine is on tracks. You can take it off, put it in position, and go to work immediately. And then when you're done, put it back together. And so something that didn't require 2 or 3 days of setup and tear down. We think gantry-based systems have their place. We think rural Alaska is probably not that place. It makes a lot of sense in a more urban environment, especially if you're doing something that's got verticality to it. But we wanted something that we could basically print two stories up and 1 story down, fit on and off a trailer with the pump mixture and the hoppers, and everything else would fit in there. And that gets really important as you get to the towns smaller than Nome, because here in Nome we do have a port. You can get a maximum 54-foot container on and off the docks. But as you go to smaller communities, 20 to 30 foot is kind of your maximum that they're set up to basically take things off, and so they can't get the big seagoing barges. Mm-hmm. They're smaller barges. Sometimes they're river barges that go up the Yukon-Kuskokwim Delta. And again, that's a race there in Bethel to get up and in position, before ice up and back out again. Mm-hmm. And so that was a really important design consideration for us, is that small form factor. And then instead of going around in a gantry, you just basically print a section of wall, then move the printer and print another section of wall, and you can print as big a section as you have, as long as you have material to print it.
Another really unique part of your printer is the generator mounted on the printer itself. So you have 480 and 240.
Right. Well, we thought that was really important, that we bring all the energy that we needed to the project. Adding diesel fuel, of course. So it's a diesel generator, and diesel is pretty ubiquitous in Alaska. There's basically nowhere with any town of 50 people or more where you can't get diesel fuel. But if we didn't have that, the idea of getting a 480 3-phase power to a location in remote Alaska is just not going to happen, and you would then be bringing another generator, and so we just incorporated it all into the design, and then we brought, as you saw, all the plugs on the back, so we can run the mixer, the hopper, basically anything we want to operate. Then there's I think we have an onboard air compressor. We have as much as we can possibly put on there. I saw some of the guys the other day using it as a very expensive iPhone charger, but it works. And I think that was a key consideration, that we basically be able to come and then operate everything on the power. And then, a diesel generator is heavy, but heaviness is a design consideration. Our units are about 12,000 pounds, which is not nothing. But we tried earlier versions that were lighter, and we were having trouble with precision. And so we need something of mass. So when that robotic arm is at full extension, you don't get any motion or wobbling, and you can get precise placement of the material. And a lighter version, and you end up either having to you can't print out as far, or you end up with a wobbly mess.
Yeah, especially even the gantry systems will have a 2-ton or a 4-ton block under every single vertical axis. So at least yours is the weight is dual purpose.
Yeah, yeah.
It seems like a major logistical benefit having the generator on the printer, because normally when companies are printing on site, it's like a game of Tetris trying to move around the printer, the generator, the mixer.
It's a bit of a dance. Yeah.
And oftentimes it's much harder than they anticipate. If they don't have enough space on the side of the building, you're able to have all of that equipment on the pad inside the building.
Right. Yeah, and like in the case of this building, we're printing on the pad, and then the very last wall will come off the pad, then print back on from the basically the street side, so that we don't print ourselves in and can't get out.
And it reaches a maximum height of 22 feet.
22 feet, and then we're designed, it'll technically go further than 20 feet in width, but not all the way to the top, because as the arc goes, you end up narrow and narrower. But we designed it to basically, 20 feet is a requirement for some of the existing codes. Here in Alaska, we're basically following the same code law that would be used for like a concrete cement wall, like a basement wall, or with the cement blocks, which then requires basically some sort of a break at 20 feet. And so we just designed the printer to fit within those parameters, which also, a bigger printer that could print 25 feet or 30 feet we couldn't fold the arm up and get it to the 20-foot Connex anyway. So it just kind of worked out. So
you picked a unique arm. It starts with a Y, but it's much lighter than some of the other robotic arms.
It is, and they're a great Japanese company that they've got a facility out in Ohio, and Yakisawa, and they're pretty badass. We're pretty happy with that.
It does seem very stable. The weight, the lighter robotic arm.
Yeah.
A lot of companies struggle around the corners, but you guys seem to have. There's no wobble.
Right.
The other thing you guys avoided was cold joints.
Yes, in our design, you mean? Yeah, and so we're using a pinch valve to basically start and stop the material, and then basically the design we're doing here, different places, different designs. Certainly, you wouldn't need all this in Texas. Just the thermal mass you would get from a wall alone will get you what you probably need there. I mean, I'm no expert in construction in Texas, but I assume they want an R10 or an R20 kind of a configuration on their walls, which you can get above an R10 just with the concrete. So, so probably not a lot of need for a bunch of Owens Corning foam in those situations. But here, we need a lot of foam, and so we basically have an interior wall that's structural, that's load bearing, and then we have an outer wall that's more, it's providing, because our concrete is so dense, it's providing a waterproof seal and a barrier, but it's also, it's providing us a gap where we can then fill the foam in to get that insulative value, and so, it kind of works well that way.
Yeah, fascinating. A lot of groups don't cut the edges of the wall just because I guess it's not as demanding from an insulation perspective.
Yeah.
So
yeah, so what you see, there's basically a continuous around the outer perimeter. It's completely filled with foam, other than where there's a door cut out or something like that. But even so, right up to the door and above the door is foamed in as well.
Is it double or triple pane windows?
We're using triple here. It depends on where you are, but you know this is kind of triple pane glass place here, and then you get into the you know our boxes. We're not using any wood. You see how it is here. You know we're 4 blocks off the ocean. It blows sideways until the ocean freezes, so you get that salty, rainy mix of rain and sleet for, you know, during the part of the year when the ocean is open. And so we don't want any wood in the boxes, anything that could be susceptible to moisture or rot. We're trying to avoid that, and then we're looking to make sure that the windows themselves, whether they're vinyl or aluminum or whatever they have the right kind of thermal breaks in them, because if you you know, it's not unusual here for it to get down to, you know, -40 and more, but you know -40 is not uncommon. You know, any kind of area where you have either metal or anything that will basically create a thermal bridge will ruin your insulative value here, and then you'll end up with basically frost on the inside of your house, as it will basically wick that cold in, and you know, basically up against your wall you'll be, you know, basically below freezing, which will then, you know, start a little ice sculpture for you on the inside of your house. So got to avoid those things.
Plus, the sand and the wind is abrasive.
Very abrasive here. Very abrasive. That's an area where we're still doing a lot of experimenting. You know, my partners at the Local 528 are cement masons and plasterers, and so, you know, they're experts in stucco and various kinds of mortar finishes. You know, if you tour the town here, you know, you'll see a lot of homes with a lot of missing paint, and that's you know, that's because we just get wind blast. It's like being sandblasted all the time, and so, you know, we think that the concrete mix that we've developed, because it's so strong, is really going to hold up to that well, and we're going to experiment first with an elastomeric paint on this. But we have a design for it with you know, some other materials that are color, and you know, we basically are putting the color in the material, so that as it gets sandblasted, it will remain the same color.
Nice.
You know, and that is a real issue here.
Another challenge is occasional flooding.
Yes. Well, we get yes. Yeah, we think that you know. I'm working with some other folks down south who were involved with, like, the Kentucky floods and some of the North Carolina floods and some of those, you know, really bad things. And we think that 3D houses can have can be really important there, especially you know, because you're not limited to rounded edges. In the same way that if you look at, like, the most effective hurricane structure is like a round obelisk building, which, you know, a 3D printer can print very easily, where there are basically no edges for the wind to grab and rip your roof off. The same thing goes with a flood. If you have rounded edges around your foundation,
Makes sense.
then, you know, basically the water will go around you and not basically underroad or erode and rip your house away. And so, you know, these show really good potential for you know, Cat 4 and Cat 5 hurricanes, for floods, and for fire. I mean, the fire rating on these are phenomenal.
Someone was saying houses around here typically only last 25 years or something like that in good condition.
That's true. It's the same in Hawaii too, for different extreme of weather. But yeah, you know, that is a real problem in an environment like this, because, you know, one, not only are the homes here 2 or 3 times more expensive than the lower 48, they basically depreciate out in 25 years, where, you know, typically, you know, the U.S. housing infrastructure has a median life of like 50 years. And so we're half of that, and so you don't even have your mortgage paid off, and you basically have to replace your house. And I've seen that with friends in Juneau who, you know, have, you know, had to totally rebuild their house and spend more than they spent to build it, because they've had water intrusion or other problems.
It's wild banks are still lending on them if they are expecting them not to last 30 years.
I don't know if that's willful disbelief on their part, because otherwise there would be nobody with a house. but we're thankful that they'll live on 30 years. But and of course, it just means that people are their maintenance budgets are so much higher here because if the roof only lasts 12 years instead of 30 years or 25 years, they've got that extra they've got those extra costs to keep it up. I mean, certainly a house will last longer, but only if you're spending money as you go. Which typically speaking, when we're talking about these numbers, that's if you don't keep it up 25 years, you're going to wish you had because it's not going to be there anymore.
That should be a big advantage of your house. It should last a very long time.
It should. It should. And we're working on kind of every element of that to make sure that these are cement structures that are going to they're kind of castle-like in many ways. But if you tour Europe and you see these old structures that are there, it may be 500 or 1,000 years old, and what's left, it's the stone walls, right? The windows are gone, the doors are gone, the roof is gone, but the stone structure is there, and so we feel really good about the stone structure, but we're working equally hard on roofs and other ways to make sure that the other components can kind of last the same way that the rest of the house lasts.
I was amazed one day we were here, a huge 2x4 fell on a small piece of a printed wall that was only 2 layers thick.
Yeah.
Snapped the 2x4 in half with not even a mark on the printed concrete.
And that was only concrete was there for like a day.
So it didn't even fully cure.
Right. And I think at these temperature regimes, we're thinking maybe 28 days for a full cure. But even after a day or so, it's pretty solid. Mm-hmm. But it's not at 7,000 or 9,000 pounds of tensile strength. It's maybe at 1,200 pounds of tensile strength.
Something like 8,000 psi.
Yeah, it depends on where exactly the material came from. It's been in a range from 7 to 9 as we've tested. So 8's safe.
Do you know who will occupy the house, or the city will?
We don't know who the house. I'm hoping the city will let me stay in it. We have a great partnership with the city here of Nome. We formed a research partnership with the city of Nome and Penn State University as we began this project. And the city is looking at needs everywhere, and housing here is very, very limited. And just having the help of the city on our part, has made a big difference in being able to keep people up here and not have basically all the government's grant money going into the to the hotels here, which are very expensive in the summer.
Mm-hmm. So, what are the things that you need most right now to grow and achieve your mission?
Well, I think that in order to scale, we're going to have to be able to, batch and produce our own material here locally, which was going to require things like a sand dryer and various mixing and batching things that just don't exist here. Mm-hmm. So we're looking for grants and opportunities for that. And then as we move out into other villages and other places. It's just so expensive to do anything here, and I don't know if your viewers have, I know that like me personally, I've at my house now I've decided with my own personal tool collection, I went yellow with DeWalt, and don't know that that's best or not, but I had more DeWalt than I had anything else, and so. When my son wants to borrow something or my son-in-law, it's like, oh, here's a really beautiful Milwaukee tool or a really beautiful, there's nothing wrong with them. They're perfectly fine. It's just that, we're now in this thing with the batteries. Where,
sure.
So if somebody's gone red or rigid and then has some DeWalt things that they want to donate up or we don't care, what it is, anything like that, we are 501c3 not-for-profit, and we basically need one of everything.
You mentioned trucks too.
Trucks are really expensive. We've had some help with some of the local shipping companies. Us as a nonprofit, yeah. But if somebody has like an old 2500 or 250 or 150 or Suburban. anything like that, if we can get them, out and placed in the villages as we're doing projects, otherwise it's thousands of dollars out and thousands of dollars back, and so, but a good American-made truck like that lasts for decades, and so maybe we have some good viewers who've fully depreciated them, and looking for the new ones are pretty nice. We'd love a new one, but it doesn't make a lot of sense here. But we would then put them out regionally in places where we're going to do projects, and because you say you can't just drive it from A to B here. It's got to come out on a boat.
Yeah, we'll put a link to the Extreme Habitats website in the description so people can reach out and figure out the tax benefits and whatever paperwork needs to happen.
Perfect.
Extreme Habitats isn't fully dedicated to 3D printed construction. It's interested in all kinds of construction technologies.
Yeah, we're interested in automated construction generally.
Me too.
And we love our 3D printing project. We spent a lot of time and effort getting here. We do not believe, or would we advocate, that a 3D concrete printing will solve all of life's problems. There are places where 3D printing makes a lot of sense, like here in Nome, and there are places where it's not going to make any sense. And I'm sure that's true in the rest of the world as well. But our challenges here are cost of materials. It's not really cost of labor here as much as just availability of labor. And so even in a project like here in Nome, where we have 3,500 people, there are some licensed plumbers here. There are some licensed electricians here. Very few. They're backed up for the next 20 years. As I did this project, I tried to hire locally every step of the way, but I ended up flying in electricians from Anchorage, plumbers from Anchorage. That's not uncommon. And so anytime we can look at technology or projects where folks who haven't been in an apprenticeship program or in a long-term program, who, people in Alaska are pretty handy. Mm-hmm. They can typically, run a circular saw, swing a hammer. They're very industrious folks. You have to here, you're going to die. Especially as you go Nome and further from Nome, and maybe in Anchorage you can survive just fine, and there's a Home Depot and folks can but as you get into rural Alaska, you really need that. But so we have people with certain skill sets, but not necessarily the trades. And so anytime we're looking at an automation solution or a construction solution where either it's prefabricated and the electric is already pre-run or the plumbing is pre-run. Those have a lot of interest for us. We can bring things in modules and
Mm-hmm.
then hire local folks for the construction, and maybe then following code, you may still have to bring out a high-level electrical person to do a final inspection and sign off, but you're not oftentimes as I'm doing things considering doing things in more remote places, I have to build a structure to house the people that I need to come and build a structure. Yeah. And so, all the above are really kind of on the table. For your partners and folks who are into different kinds of robotics, we'd really like to talk to them. Folks who have other kinds of automated solutions. Look, if it won't work, if it will work here, it will work anywhere. And some of the work that we've done has, and some of the people who've been involved in this, like you met Sven,
mm-hmm.
Dr. Bellin. He's been involved with NASA and the NASA competitions, and if you can't figure it out here in extreme Arctic conditions, you're never going to do it on the moon. You're never going to do it in these other places, and there's a lot of talk about that. And so we're really a very good testing ground for those kind of things, and Extreme Habitats wants to be part of that.
The other day we were in the shipping container while it was raining, and you were talking about outfitting it with heater, cot, stuff like that. Yeah. Would that be a temporary housing solution for people in a more remote space, or?
Well, it can be, and it has been. We've done some things around basically these foldable structures that you see those on the internet a lot, and from pricing down to 10 grand, which is very sketchy, to 100 grand or more. But we were able to work with some manufacturers who have a good reputation to basically create Alaskan versions of those with R30 or R50 in the walls and triple pane glass and all the things. And so that is a real good temporary solution to basically bring in basically a tiny home that's maybe 400 square feet or so, unfold it, and you may still be on a latrine kind of situation, but you at least have somewhere warm and safe to stay while you're then building the project you're building.
If it's a housing project, I guess once you get a couple built, you can start putting people into the first units.
Yeah, which I think is hopefully what we'll do here. And this unit will be a 3-bedroom, 2-bath. It'll be a very nice unit.
Have you started talking about what the next project after this would look like? How many units? Or
I have talked to the city about several projects. They'll have to make their decisions, so I don't want to get too ahead of them.
Sure.
But they're kind of like me. I'm kind of a Missouri kind of guy. You got to show me, and so I think that if we get the results that we expect, I think we'll be plenty busy.
That's terrific. So Extreme XHab, which you guys work closely with, that's the for-profit startup
Sure.
that builds the printer. They'll be selling the printer. What do you think they need the most right now to grow? Are they seeking investment, talent?
I think they're doing all of that. I think that they've been through a couple capital raises and I think they're currently in another one. I think they have a lot of talent. I think they need guys like me and folks like your viewers who have good projects to basically demonstrate the tech. And I mean that's kind of what we're about. We want to help demonstrate this tech. We're looking at doing some projects in Hawaii over the winter, and North Carolina and other places. We just as we go further and further in 3D printing, what we want to do is then take our knowledge and then transfer that to the public sector, to either housing authorities or cities or private builders. I see a lot of private builders who are interested in 3D printing, but maybe don't know where to start or can't afford to are unwilling to take that risk of spending a lot of money buying a 3D printer when they don't know exactly how it's going to go. So if those kind of viewers want to talk to us, we'll share anything that we have. Any of our data, our cost data, anything we have is public. We're not trying to become a large builder. We're trying to advance the technology and find what works, and then see it, try to get it out in the marketplace, and then find something else that works.
Yeah, another thing you mentioned is you want to keep your material. You have a proprietary material solution, but your customers wouldn't be restricted to it.
Right. Well, yeah. Well, of course, we're working here with you see these temperatures, and so we just proved that it doesn't work very well in a hot environment. We were doing a project with this material, and it was 100 degrees down to lower 48, and didn't work at all. But it seems to be working okay here, all things considered, even though we've had a few quality control issues with the mix. But the mix itself is doing what we want. It's setting up well. It's holding the weight. It's doing what it was designed to do. So it would be the wrong mix for somebody in Ohio, unless they want to print, in February. Then it might be the exact perfect mix.
Bruce also mentioned back to the recruiting talent thing. Yeah. He mentioned he wanted someone really good at software, some high-level software person to come in.
I'm sure he does. Yeah. That's more my background, but I'm past that. So
different kind of software. Such a big.
Yeah,
industry.
I think that we're talking about Grasshopper and Rhino and maybe Python and the skill and then it's integration. So much of it is successful integration, especially as you start. They're working with like Total Station, which is a Mac Daddy super cool kind of product. Expensive, but it's a really good at what it does.
That's a cool thing to talk about.
Yeah, and and so there's integration necessary there. When I was a puppy, we worked on developing one of the first integrations of Oracle's relational database, and Esri or ArcInfo, which was basically the stuff that maps out where the pipes and electric and things are in your streets. And then being able to basically take things in and out of Esri and store them in a relational database, which when I was first coming into the tech career, people were like, relational databases, what are those, and will they last? And now, you can't find anybody doing anything that doesn't use a relational database, and we've forgotten what those other kinds of databases that existed before even are. I mean, I could name them, but your viewers don't care.
Data's become a real commodity.
Yeah.
So the Trimble station you have maps out the site so that the printer understands its relative location.
Space and time, yeah, down to the millimeter or below millimeter.
Which is how you're able to then hopefully move the printer faster. You don't need to do the same manual placement.
Yeah, last year we were doing manual calculations. Now we're able to use the computers to do it. I think, I don't know that we're saving any time on this project, but we're getting a lot of important data, which I think will save time on future projects.
Not to mention future integrations, like they mentioned, you might be able to put a saw on the system or spray foam with the printer, paint stuff. You already have the robotic arm, so you can add more tools potentially.
We can, and I think our Extreme Habitat's next project will be working with our foam manufacturer to basically, be able to basically place the foam into the walls using the printer to do that.
That's a non-expanding poured foam.
Non-expanding, hydrophobic, closed cell, polyurethane foam, yeah.
Is that something you'll mix yourselves on site? Does it get stored in a vat?
They usually come in containers or barrels, but yeah, we will be doing it on site. Of course, in this on the house that we're looking at, we'll do that manually. There'll be guns and hoses and things, but we won't be using a 3D printer on this print. But we're working to modify the arm to basically take the application gun, which shouldn't be that big of a deal. I mean, you can put TIG welders and you can do, these robotic arms are widely in use in automotive applications all over the planet.
It's also getting some serious weather testing. It's been raining sideways all over.
and freezing overnight. Yes, it has. And mostly has done pretty good. We had a cracked
servo.
The plastic sheathing that holds that servo, where we had an impact or something that somebody didn't notice, and so it was cracked, and so a little water got in there. So something that a hairdryer didn't solve for us. And then we've now resealed it, and it doesn't seem to be doing that again. But yeah, that's certainly, if it survives here, folks who buy this same system down in the lower 48 or other places in the world shouldn't have much to worry about. And if it wasn't such a remote environment, we would, move it inside at night anyway, or we wouldn't, and of course, we're going to print in weather that I would say very few of your listeners or viewers would ever try to print in, because we have to, because that's the weather we have.
Yeah, the only projects I've seen that approach these kind of conditions printed in a covered tent with temperature control. And
Right. Well, and we have that solution. It's just not cold enough for it. Excuse me.
The tents are very expensive.
They are, but my friends at Union have them. But it needs to be, we need a bigger temperature differential. It's too warm to deploy basically the inflated balloon that basically sets over the entire site. Because, sometimes there's a runway cracks or there's a problem in Alaska in the winter. And so they can print at 20, they can do concrete work here at 20 below. They have that skill set because they have to. It's not like, they would never voluntarily choose to do a project like that. But if they have to, they have to.
How do they get around the freezing? A lot of places wouldn't print concrete in 31 degrees.
Yeah, they put antifreeze and stuff in the concrete mix. Yeah. I hope you'll get a chance to talk to my guys there. They can answer those questions in a lot of detail. I only know the stories they tell me about how they didn't lose their fingers that day.
Yeah, there's some wild stories of people up here. They really make them tough in Alaska.
They do, and it's a you know it's an environment that attracts a lot of unique individuals, a lot of very interesting people.
Even just getting off the plane, it's like, okay, we're not in the lower 48 anymore.
Yeah,
Anchorage.
yeah, and Anchorage is a more normal American city.
Mm-hmm.
But once you get outside of Anchorage, even Fairbanks or Juneau are, uniquely Alaskan in a way that Anchorage, I'd say, is more of an American city with a lot of Alaskans visiting. Of course, that'll make a lot of Anchorage people upset, but I think they know what I'm talking about. They're minutes from the real Alaska, but they also have all the benefits of, fast food restaurants and big box retailers and prices that aren't triple or quadruple what you're using to pay. So it's just more like America. Somebody could make an easy decision to move to Anchorage, and it's not that much different than being in Sacramento. But certainly to make a move to a town like Nome, it takes a certain kind of person to be able to do that.
Certainly. I don't think it's for me. I don't know if I'd make it through the winter up here.
No.
You've uniquely visited most of Alaska.
I've been around a lot of the native villages, and either as doing photography, safaris, or as part of other work that I did, either for the state or for other nonprofits. I've got to visit a lot of rural Alaska. Mm-hmm. Yeah, very, very grateful for that.
If somebody were to visit Alaska, if they were there for tourism to see the beauty of Alaska, what time of year should they go and what part of Alaska should they go to?
Well, it certainly depends on what you want to do. In southern Alaska, we have the Inside Passage, which is world famous for cruising. Mm-hmm. In Juneau, we were visited by most of the cruise lines on a weekly rotating basis. They're coming through. Cruises are a great way for your first visit to Alaska because you'll see a lot of different communities. And then you don't have to worry about transportation or the cost of lodging. It can be a really good bargain. Personally, I would stay away from the late season specials, and if I wanted to, save money, certainly if they go in peak season in July, they're not going to be wrong to do that. But not everybody maybe wants to spend that kind of money. If I were making a trade-off between a late season, which you're kind of seeing now, we're getting into where it rains a lot. Or an early season, I tend more towards the early season. You'll get more clear days that way. If you want a different kind of experience, maybe, and you're not going to take the drive all the way up the Alaska Highway, I consider renting an RV.
Cool.
They're very affordable. I've recommended that for several folks. I've done it myself with my kids. I used to be an RV owner when I lived down south. Didn't bring it. I switched over to a boat, which is just a more expensive version of an RV that costs even more to maintain. But renting an RV and then driving the part of Alaska that does have roads, so you can basically go from Homer down in the Kenai Peninsula up to Anchorage and then around to Fairbanks and over to Tok and Valdez. And so you can spend a week on the road system. Alaska's pretty lenient about where you park and stay, and so you can either stay in a campground or you can pull off to the side of the road. Nobody's going to bother you. It's sun shining most of the time anyway. That's a really affordable way to see Alaska, especially when you say, if you had to rent a car and then spend, $500 a night in a hotel, that $1,500 for a week of an RV rental looks pretty affordable pretty quickly.
Alaska seems pretty lenient about most things.
Yeah, I think they're, I think there's a strong libertarian flavor to the state. and basically a live and let live, and just leave me alone and I'll leave you alone.
If you could survive, you're welcome.
Yeah, but at the same token, there's a real sense of community. If you are in trouble, people will stop and help you. Um, uh, you know, uh, there's crime everywhere, but from my experience, the crime levels here are pretty low, and people tend to not lock cars, doors, property. Um, Jeff, our construction VP, has experience in building in, some of our inner cities, and it used to basically, if it's not locked up, it's gone in the morning.
Yeah.
And we've had no issues here with stuff. Now we don't irresponsibly just leave things scattered here and there. We put things away at night, but even so, there's 2x4s and things that easily be toted away that and nobody's touched.
Which is especially impressive because of how hard some things are to come by here. So someone could drive by and need something.
It is. But but if they need it, they just come and ask. We've when we were doing the pour on the foundation, we had folks come by and we had scraps where we were doing the forms and stuff, and they take it away and they're gonna go burn it.
Yeah, I heard about that problem in Nunavut, which maybe could be a future region where you guys would be uniquely qualified to print.
Yeah. I've been several times. I went with the U.S. ambassador to Canada on a trip over to Whitehorse, and there've been several other cities in Canada that are natural, the same basic issues, same basic everything.
Mm-hmm.
Where I am where I live in Juneau, even though there's a 100-mile long by 40-mile ice field, separating the two countries, I'm really much closer to cities in Canada than I am to cities in Alaska.
You were saying the native Alaskans, a lot of them haven't really seen much of Alaska because it's just so challenging to get around.
So expensive. It's just so doggone expensive to travel the state. And so Alaskans are really well-traveled people, but most of them are well-traveled to the world because it's so much less expensive to go see other places than it is just other places here in Alaska.
You're saying you can get to Frankfurt cheaper than some other Alaskan
to a village that's 50 miles away from the village you were raised in. Yeah, so go to Europe instead, and so they do. So I say Alaskans are, if you have any conversation with an Alaskan, they're going to impress you with the places they've seen in the world, but they haven't seen, when I, growing up mostly in the lower 48, you go visit the larger towns in your area because we got roads, and you can go drive to Kings Island or drive to Kings Dominion or drive to Six Flags because it's 3 to 6 hours away. Not the case here.
Here you have like 3 to 6 hours of roads to explore total, and then that's it. You run into, I guess, the woods, the mountains,
or a bay, or something impassable will stop you in every direction. Yep.
What are we missing?
Well, what do you want to talk about? Talked about what Extreme Habitats wants to do, or what they're doing.
What does your ideal client look like?
My ideal client? Well, it's in 2 or 3 different areas. One, we want to work with kind of the front lines on the housing crisis, which in the case of in Alaska, a lot of times that's our local governments that are kind of really working hard. The mayor in Anchorage has a 10,000 home initiative that she's working on. I think she's doing really great work over there. And then it's the nonprofit communities or the housing authorities. There's a lot of housing authorities in Alaska. A lot of those are, some of them are municipally owned, some of them are tribally owned or Native corporation owned. Good folks to work with. Continuing to work with the government where we can. We'll see. So far, the Trump administration has been very open to dealing with the fact that America needs houses and trying to do something about that. And so, the folks at HUD have been a really good partner for us. The new team that is in there seems to be pretty sharp and focused in on this. Typically we think of HUD as it's housing and urban development. You don't think about them working out here in rural Alaska, but they do, and they do a really great job of trying to support us. And there's a strong HUD office for Alaska only. A lot of states don't have that. And then we have a regional group out of Seattle that's very supportive. And I'm not the guy who's going to get a contract to build 100 units of low affordable housing, but they have groups within HUD that are doing basic research and basically trying to develop the kind of tools to push the costs down. And then they have a showcase that I think is coming up in DC in a week or two that was started by Dr. Carson that basically showcases innovative building technologies. And I've gotten good ideas just by going to that showcase, which is on the National Mall, and talking to people.
You mentioned energy in the beginning of the conversation. Is Alaska connected to the West energy grid, or is it an independent energy
grid? It is completely independent here, and there really is there is a small grid, and what in Alaska we call the rail belt, which is basically that part where there's a road, there's a road and a rail that kind of connects that I told you to go take the RV tour to. That has a grid, but the rest of the state are islands, and they're not connected.
Yeah, someone once told me Texas is the only state with its independent energy grid, and then they joined the other two.
Well, yeah, other states have grids as well. I mean, now we're in a different part of my life over at Juneau Hydropower, but there are small limited grids in different parts of the state, but in general, we are not connected to the U.S. grid, and the U.S. grid connects a lot of Canada, the lower 48, and Mexico. They're all under the same basic. You can basically move an electron. You can market an electron that was produced in Canada to a customer in Mexico through that grid. That is a dream to get Alaska connected to the American grid. We have a lot of energy potential here, but not necessarily a suitable market. So we might have a really nice hydroelectric facility or other kinds of facilities that could be established here, but there's not a and so it's this much energy. We have this much customer, which makes it unaffordable to develop it. But if you had access to a grid, then it could be developed. And so
that makes sense.
Yeah, and so there have been plans to do that from time to time, but to date it's never happened.
It would need to traverse. Do you know offhand what distance to get it connected?
It depends on the plan. There was a plan to basically come through southeast Alaska over to British Columbia to the existing British Columbia grid, which then connects the lower 48. That plan was last seriously looked at maybe 15, 20 years ago, and there are other plans that could bring you to Alberta or to other points.
What's something maybe challenging or opportunistic in energy that people often overlook? Is there anything like that where people are unaware of some either principle of energy or something a potential solution?
Yeah, well, as a renewable energy person, there's tidal, there's river energy, there's wind energy, solar energy. There's geothermal energy. Here in Alaska, we have a lot of volcanoes. We're on the 3D printing side, we're looking at volcanic ash as a possible
That's cool.
admixture tool. But nearby are volcanoes, some of them active and some of them to be active again in the near future. There's a serious initiative that's been going on for a while out in Dutch Harbor, on Alaska, Dutch Harbor area, to basically tap a volcano for a geothermal resource. I think that's a real potential out, especially out the Aleutian chain, as you're moving to, because almost, in the same way that Hawaii is volcanic, the Aleutian chain is volcanic. And so there's plenty of energy out there that can be developed that way. It's not my area. I'm more in the hydro area, but it's good stuff. It's good stuff. Of course, the state is looking at a pretty serious initiative to try to bring liquid natural gas to saltwater, meaning to saltwater that doesn't freeze in the winter, because it's near saltwater up on the North Slope. It just freezes for half the year. That seems to be gaining some traction. So there's potential for LNG export to the world in the same way that our oil pipeline exported, as it's been exporting oil to the world since the 80s.
Interesting. Have you seen any commonalities you can draw from microprocessors and being involved in computer infrastructure projects to 3D printing, where you kind of saw that industry develop from pretty early space?
I think that as I look at this industry, there's a point, there you have your initial pioneers and your early adopters, and I don't know where we are in 3D printing, but I still think we're kind of early on. Probably much earlier on than some of the folks who are more involved in raising capital and trying to bring products to markets would want to admit. But there becomes that point where you cross the threshold, and then adoption can become a real thing, and that's really where I'm trying to concentrate. Because I think XHab is a great product. I think there's a lot of great products out there. There seems to be a real lack of skill or experience of then taking these great products and then figuring out how to usefully implement them, and then how to get the metrics around that in such a way that it becomes repeatable, where one of your listeners can, call me up from Alabama or wherever they're listening from, and say, "Hey, what did you order? What did it cost? What are your returns? And and I've got, this 5 housing complexes I want to build with this." I just don't feel we're there yet, and that's a place where XHI as a research nonprofit, can play an important role in basically, trying it and learning the lessons, and then sharing those lessons freely, rather than being a proprietary business where we want to hold that as a key advantage to grow our business. Well, I want to grow my business by being valuable to the guys who or ladies who would do that kind of thing, and then have success with it, and and then kick it in kind of into high gear, because I think it's the same with, when I in tech, you have those kind of killer apps that grow in industry. When I first started in computers a billion years ago, the first app that really, first it was word processing. It was basic word processing, and you had old systems like Wang, which you guys can look that up. And you had WordPerfect, and you had basic WordStar, WordPerfect, eventually Word, but it really didn't kick off until a little product called Lotus 1-2-3 came out, which now we don't hear of those anymore, but everybody knows about Excel, which is basically a derivative of what they did at Lotus 1-2-3. But with that killer app, businesses saw real value in investing in these personal computers, and and it led to wide scale adoption. Yes, there are people who are using them to replace typewriters, but then the typewriters still work. But then when you had that second thing, then people bought in, and then as the industry grew, we had an area where CAD CAM, having CAD CAM really drove computer adoption, and then being able to do movies, and there were these kind of levels that drove our computer and our computing technology. And now our computers, if they have cool things now like solid state drives and lots of RAM, but the computer that you go to Costco and buy may not be as powerful as it was a few years ago. It's got some better features, because for 90% of the people, they don't need it anymore. Everything is being now on the issue of like servers. Oh yeah, the more power the better, but you don't need that on your personal computer anymore. The industry kind of went through that. I think with automated construction, we're gonna see the same kind of thing, and there will be some killer apps that just explode this.
That all made me think about, if there was one kind of defining seed change, maybe it was user interfaces, where
Yes.
suddenly people who weren't computer scientists
Right.
could interact with
Right.
the technology. And 3D printed construction,
Right.
automated construction needs that same thing, where a general contractor can
It does.
have a good user interface and integrate it.
Yeah, and I think that the XHab has solid user interface, but it can always be improved, and it really needs to be, and I used to do a lot of that kind of work, where we'd have really powerful stuff, but now, how do you make it so that the average person can use it?
Idiot proof.
Well, I had a goal on any software. I did a lot of white label software, where software that other people would end up marketing or selling. But for any one action that I would do on a computer, I wanted to have 5 ways to do it, because people have different ways of thinking, of processing things. And so, if you're a real powerful user, maybe you want to control keystroke. For me, it's like, go to the file, go to the menu, pull down 14 layers and find the thing that I want to do. But for somebody who does this every day, they don't want to do that. They want to be able
Shortcuts,
to,
search
they want
bar.
shortcuts, different ways to do that. And I don't know that any of the folks in 3D automated construction are there yet, because it's kind of coming right out of the lab. And so then it has to come to companies like my old company, who would then give that robustness to it. And then I did a lot of work in what's called IV&V, independent verification and validation, where I would do stupid things like lay my hand on the keyboard and see if it crashed the software. Do everything that you weren't supposed to do, and how robust was your system in handling that. And of course the engineers would be losing their lunch on me a little bit there. They'd be so upset. Well, you weren't supposed to do that. Well, I understand, but that's real life is real life.
You prevented 100 customer service calls down the line.
Exactly. And so I think it'll go through that evolution. But now we need early adopters, folks who are willing to kind of take a chance on the technology, who either have the means, or have a customer, or have some reason, who want to be part of that experiment to see, can I actually make it work? I hope we get to talk to some of them.
Yeah, for sure. I'm sure you already have, and will continue to. In terms of like how early it is, I think in the future all homes should be built with automation. Millions and millions of homes every year.
Right.
And right now it's like a couple hundred are built with automation. So it's like really just in that.
Yeah, and I say again, I'm hoping to get calls from your viewer base, because we're doing the walls in 3D printing. We're looking at SIP panels and certain technologies for like our roof. But if somebody has a robotic machine that puts up an interior piece of drywall, or helps install a cabinet, or whatever it is, we want to look at it, and we want to try to integrate that into actual real life situation where it can be put to use.
I'm sure that would be great for them, especially since you have the Trimble set up. It could probably integrate with their software, even if they're not using Grasshopper.
Sure.
I'm sure Trimble has a variety of softwares that.
Yeah, and Now, of course, like that, we know I'm aware of some of like the extruded wood printers that are out there, and I think those things are outstanding. I love them. They're just wrong for Nome because we have no trees, and there's no, I would have to import whatever the material is that's going in there 100%. But in other places, as you move down into Southeast Alaska where we do have trees, or British Columbia, it would make a lot of sense.
Before we wrap up, can you describe the projects that you're hoping to do in Hawaii and North Carolina?
Sure. In North Carolina, we're talking to a 3D printing company there who, is committed to building a small community of 3D printed homes, we would use this XHAB technology for that.
What size?
I think there'll be 1,000 to 1,200 square feet. The designs that they showed look pretty doable. Pretty doable.
Maybe 6 or 7 walls.
Yeah, maximum 6, maybe 4 or 5.
Wow.
Yeah, I mean, it just depends on the, how we set it up, because the 1,000 square feet is not that big of a box. So yeah, 6 sounds about right.
Then Hawaii.
The folks in Hawaii, we're looking at. We have a design for like a mini house, a tiny home for like. They have a severe housing shortage over there, and a homeless situation. So we're working with a nonprofit over there that's looking at that. And
Fire-resistant housing.
Fire-resistant housing. We'd love to talk to some more folks, who went through all those fires in Maui, about some designs that would hold up. Of course, they get fires on other islands too, but then the city has some ideas, and I'll just let the city deal with that as they see in their their time and their thing. But they have some ideas around some transportation projects and elements of how we might use 3D printing to support that.
Yeah, I'm sure it'll be helpful for them. You get the pilot project up, and then they can really assess a larger scale solution.
Yeah. They, our issue there that's really interesting is we're looking at trying to get a crusher to make basalt sand, because basically all the Hawaiian Islands are volcanic and they're primarily made of basalt. And even though they have some lovely beaches, I don't think they want us out there harvesting them, because they're pretty small. And probably not the right thing, and we certainly don't want to just have to ship in sand, barging it in. But if we can make an aggregate product that will 3D print with the basalt, then that could be transformational.
Basalt is a very strong rock, right?
It is. Yeah, it's one of those lower on the periodic elements, very, very sturdy. I think it'll make a really nice house.
Cool. I think that was very insightful. Thank you for sharing all that with me.
Well, thank you so much, and thanks for coming to Alaska.
It's my pleasure. State 49. Hopefully, can get to Hawaii one of these days. Make 50.
You know who somebody's going to be over there shortly. Thank you.